We have started a new topic from the organic chemistry, stereochemistry of organic compounds. Now, what we have studied in the last lecture, first one is the chiral center and second one is the elements of symmetry. Now, to show the optical activity, molecules should possess at least one chiral center. This is very important conditions for optical activity. That means one carbon should be attached to the four different atoms or group. Then that carbon is called chiral carbon, or it is also known as the chiral center or a symmetric carbon atom. Uh, and this is the essential condition for optical activity. That means organic compound molecules should possess at least one chiral center. Then second one is the elements of symmetry. There are three elements of symmetry: center of symmetry, plane of symmetry, and alternating axis of symmetry. And molecule should not have any element of symmetry, then it is optically active. That means absence of element of symmetry is the essential condition for optical activity. That means molecule should not have any element of symmetry, and thus these are the two essential conditions. Now, what is meant by chiral molecule? Suppose any molecule having chiral center and it do not having any element of symmetry, then that molecule is the chiral molecule. If molecule having chiral center and it do not having any element of symmetry, then it is chiral molecule and it is optically active. That compounds are optically active compound. Okay. Then there is one more term, achiral molecule. Suppose a molecule having chiral center. If there is a chiral center and if it possesses any element of symmetry, then that molecules are called achiral molecule and it is optically inactive. Okay, we have studied in last lecture these four important terms: chiral center, elements of symmetry, chiral molecule, and achiral molecule. Now let us see next, again a very important term regarding the optical isomerism. What is meant by enantiomers? First, I will explain a very simple example of organic compound. Let us say example of organic compound. This is the organic compound CS3, CHOH, COOH. Name of the compound is the lactic acid. Name of the compound is a lactic acid. Now, to study the optical isomerism of any organic compound, we must know, is it having chiral carbon? We must know, is it having chiral carbon? This is the first essential condition, that molecule should be contain chiral carbon. Now, what's about the lactic acid? What's about the lactic acid? Is it having chiral carbon? What's about this first carbon? That carbon of methyl group is not chiral because it is attached to the 3 hydrogen. But that second carbon, it is attached to the 4 different atoms or group. What are these atoms or group? Of course, this OH, then methyl group, COOH, and hydrogen. Means that carbon is attached to the 4 different atoms or group, and hence this carbon is chiral in nature. I have marked that carbon by red marker actually, and this is the chiral carbon. This is the asymmetric carbon atom. Thus, lactic acid having chiral center. Lactic acid having one chiral center. Now, for any organic compound, we can calculate the number of possible stereoisomer by the formula 2 raised to n. We can calculate the number of possible stereoisomer by using formula 2 raised to n, where n is number of chiral carbon. Now let us put the value of n. Suppose by putting the value of n, here 2 raised to n is equal to 2 raised to 1. 1 is number of chiral carbon. There is one chiral carbon. Now 2 raised to 2 is equal, 2 raised to 1 is equal to 2. Means lactic, we can calculate number of possible stereoisomer for any organic compound by using that formula 2 raised to n. Here in the case of lactic acid, the number of chiral carbon is 1. Therefore, by the putting value 2 raised to n is equal to 2, right? Means lactic acid having 2 possible stereoisomer. त्यासाठी 2 possible stereoisomers आहेत. Now let us see what are the possible stereoisomers for lactic acid. This is the first possible stereoisomer. I am concentrating on the central carbon. Chiral carbon. Now this carbon is attached from one side by methyl group. Yes, there is a methyl group. Then it having one hydrogen, one OH, one hydrogen OH, and there is COOH carboxylic group. Okay, this is our central carbon, which is chiral in nature because it is attached to the 4 different atoms or group. And this is the first possible stereoisomer for lactic acid. Okay, now let us see another stereoisomer, second possible stereoisomer for lactic acid, and this is the second possible stereoisomer for the lactic acid. Now, what is the difference between that two? In first case, we have shown that OH group at the right hand side, while in the second case, that OH group is shown at the left hand side. And these are the two possible stereoisomers for the lactic acid. Now let us see what is the relation between that two stereoisomer. What is the relation between that two isomer? Okay, suppose that both the compound means that both the isomer, they are optical isomers. They show optical activity. Why they are optical isomers? Because they having chiral center. They having chiral center, and there is no any element of symmetry, and therefore they are optically active compound. Both the stereoisomer, they contain a chiral center. They do not having any element of symmetry, and therefore they are optically active compound. They show optical activity. Okay, now there is one relationship between that two are mirror images of each other. That two isomers are mirror images of each other. ते एकमेकाचे आरशामधील प्रतिमा आहेत. ठीक आहे, यानंतर मी एक आणखीन कन्सेप्ट यामधला एक्सप्लेन करतो. सपोज यामधली एक आयसोमर आपण उचलला, यामधला हा आयसोमर आपण उचलूया आणि त्याला आपण याच्यावरती मॅच करायचा प्रयत्न करूया. म्हणजे दुसरा आयसोमर आपण उचलायचा, इमॅजिन करा सेकंड आयसोमर आपण उचलूया आणि फर्स्ट वरती मॅच करायचा प्रयत्न करूया. होईल का बघा? एच वरती काय येईल? इथं OH होईल. इथं OH आहे, त्याच्यावरती काय होईल? हायड्रोजन येईल. मीन्स दे डू नॉट मॅच विथ इच अदर. They do not match with each other, and this is called non-superimposable mirror images of each other. That two isomers are mirror images of each other. ते एकमेकाची आरशामधील प्रतिमा आहेत, but they do not match with each other. आपण जर एकाला उचलून दुसऱ्यावरती मॅच करायचा प्रयत्न केला, they do not match with each other. This is called, they are non-superimposable mirror images of each other. Okay, this is the second property. पहिला point काय सांगितला? That both the stereoisomer, they are optically active, means they are optical isomers. Why they are optically active? Because they contain chiral carbon. They do not having any element of symmetry. Hence, they show optical activity. They are optical isomers. सेकंड इमेज आपण काय सांगितलं त्यामधलं रिलेशन? दे आर नॉन सुपर इम्पोजेबल मिरर इमेजेस ऑफ इच अदर. एक इमेज उचलून आपण दुसऱ्यावरती प्रयत्न केला मॅच करायचा, दे डू नॉट मॅच विथ इच अदर. दिस इज कॉल्ड नॉन सुपर इम्पोजेबल मिरर इमेजेस. अँड दॅट ऑप्टिकल आयसोमर्स, these optical isomers first and second, which are non superimposable mirror images of each other, are called enantiomers. They are called enantiomers. Means here that two isomers are called enantiomers because they are optical isomers and they are non superimposable mirror images of each other, and hence they are enantiomers. Okay, and they are also called as the enantiomorphous or optical antipodes. त्यांना आपण enantiomorphous किंवा optical antipodes असंही म्हणतो आहोत. Okay, and they are differ in their action on plane polarized light. That means they having different action on PPL, out of which one enantiomer can rotate the plane of PPL in a clockwise direction. It is called dextroisomer. Suppose first one can rotate the plane of PPL in clockwise direction. It is called dextroisomer. While that second stereoisomer, it can rotate the plane of PPL in anti-clockwise direction towards left side, and it is called Leo-isomer, L isomer. Okay, and thus this is just about the important this is just about the enantiomers. What is meant by enantiomers? The optical isomers which are non-superimposable mirror images of each other are called enantiomers. In a lactic acid, that two isomers are enantiomers because they are optically active. They are non-superimposable mirror images of each other. Hence, they are called enantiomers. They are also known as enantiomorphous or optical antipodes, and they are always differ in their action on PPL. One is the dextroisomer, and second one is the Leo-isomer. Okay, this is very important term. What is meant by enantiomer? Now let us see some properties of enantiomer. थोडंसं आणखीन बघूया त्याबद्दल. Actually, properties मध्ये आपण पुन्हा एकदा तेच बघतोय. फर्स्ट प्रॉपर्टी आपल्याला काय सांगता येईल? they are optically active. They shows optical activity. मग मी मगाशी सांगितलं होतं why they shows optical activity, because they obeys both the conditions for optical activity. They obeys both the conditions for optical activity. Means they are having chiral center. They do not having any element of symmetry. Hence, they shows optical activity. Means they having tendency to rotate the plane of PPL. Means they shows optical activity. Okay, this is the first property. Second one, मगाशी आपण सांगितलं होतं, yes, they are non-superimposable mirror images of each other. Enantiomers are non-superimposable mirror images of each other. Non-superimposable mirror image relationship म्हणजे काय हे सुद्धा मी मगाशी सांगितलं. सपोज दॅट टू आयसोमर्स आर मिरर इमेजेस ऑफ इच अदर. मग यामधलं एक इमेज उचलला आपण आणि दुसऱ्यावरती मॅच करायचा प्रयत्न केला. दे डू नॉट मॅच विथ इच अदर. याला आपण म्हणतो नॉन सुपर इम्पोजेबल मिरर इमेज रिलेशनशिप. ओके, देन थर्ड प्रॉपर्टी, they do not have any element of symmetry. Yes, we know that they are optically active. Means they do not have any element of symmetry. There is no plane of symmetry. There is no center of symmetry. There is no alternating axis of symmetry. And they are differ in their action on PPL, out of which one is the dextro and second is the Leo isomer. Now, they are, means that two enantiomer, they having similar physical property. For example, their melting points, boiling point, density, etc. That physical properties of that enantiomers are similar, and they also having similar chemical properties, except their action on PPL. Means their action on PPL is different. Otherwise, they are having similar chemical as well as physical properties. Enantiomers मध्ये त्यांच्या properties ज्या आहेत म्हणजे फिजिकल असतील किंवा केमिकल असतील, दे आर हॅव्हिंग सिमिलर फिजिकल अँड केमिकल प्रॉपर्टीज. दे आर ओनली डिफर इन देअर ऍक्शन ऑन PPL. ओके, दिस इज जस्ट अबाउट द enantiomers. Now let us see. Suppose there is a equimolar mixture of dextro and Leo isomer. If there is an equimolar mixture of dextro and Leo isomer, means dextro and Leo enantiomer, then it is called racemic mixture. Means one is the among the enantiomer, one is the dextro and second is the Leo. And if there is equimolar mixture, then it is called as the racemic mixture. And we know that it is optically inactive. It is optically inactive, equimolar, that racemic mixture. Okay, now this is just about the enantiomer. Now let us see next term. Again, a very important term, diasteromers. यामध्ये आणखीन एक टर्म आपण बघणार आहोत, diastereomer. What is mean by diastereomer? Again, here also, before going towards that diastereomer, let us see example of simple organic compound. Okay, this is the example of organic compound CH3, CHOH, again CHOH, and finally there is a COOH. Name of the compound is the actually there are 4 carbon atoms in the chain. 4 carbon atoms in the chain. Therefore, it is butanoic acid. But there are 2 OH group, 2 hydroxy group. Therefore, it is dihydroxybutanoic acid. Okay, and thus that compound is called as the 2,3-dihydroxybutanoic acid. That compound is the 2,3-dihydroxybutanoic acid. Okay, now to study the stereochemistry, to study the optical isomerism, we know that there are 2 essential conditions. Therefore, we first know, is it having chiral carbon? त्या कंपाऊंड मध्ये chiral carbon आहे का हे पहिल्यांदा आपण बघणार आहोत. Is it having chiral carbon? Now, what's about the carbon of methyl group? What's about this carbon of methyl group? Yes, it is not chiral. Okay, what's about the this second one? Here, this carbon is attached to the one OH. There is one OH group. Then second is the methyl group. Third one is the hydrogen, and remaining that 4th group, last group. Okay, and thus that carbon is attached to the 4 different atoms or groups, and hence that carbon is a chiral carbon. This is the chiral carbon. Similarly, that next carbon, it is also attached to the 4 different atoms or group, one OH, hydrogen, COOH, and remaining this group, and therefore it is also chiral in nature. Thus, 2,3-dihydroxybutanoic acid having 2 chiral carbon, it having 2 asymmetric carbon atoms. Now we know that we can calculate number of possible stereoisomer by using formula 2 raised to n. By using formula 2 raised to n, here n is number of chiral carbon. Actually, n इथं हवंय 2 raised to n. Okay, where n is number of chiral carbon. Here it having 2 chiral carbon. Therefore, 2 raised to 2 means there should be 4 possible stereoisomer. That 2,3-dihydroxybutanoic acid should have 4 possible stereoisomer. Now let us see which stereoisomers are possible for 2,3-dihydroxybutanoic acid. Let us see. This is the first one. मी इथून सुरुवात करतो. This is our COOH. हा आपला COOH group असेल सुरुवातीला. Okay. Then first chiral carbon, it having OH hydrogen. Second chiral carbon, OH hydrogen, and at the end हा मिथिल ग्रुप आपण दाखवूया. ओके, देयर इज मिथिल ग्रुप ऍट द एंड. सेम कंपाउंड. ओके, फक्त आपण काय केलेलं आहे, वी हॅव शोन अरेंजमेंट ऑफ ॲटम्स ऑर ग्रुप अराउंड द कायरल कार्बन. ते फक्त आपण दाखवले. कायरल कार्बन भोवती ॲटम किंवा ग्रुपची रचना कशी आहे, हाऊ देयर इज अरेंजमेंट, ते आपण दाखवलेली आहे. ओके, दिस इज द 2,3-dihydroxybutanoic acid. त्याचा फर्स्ट स्टेरिओआयसोमर आपण दाखवला. सपोज दिस इज द फर्स्ट स्टेरिओआयसोमर फॉर द 2,3-dihydroxybutanoic acid. Now let us see next possible stereoisomer for the same compound. This is the second possible stereoisomer. Second possible. या दोन्ही मध्ये डिफरन्स काय दाखवलेला आहे आपण. In first case we have shown both the OH group at the right hand side, while in the second case both the OH group are shown at the left hand side. डाव्या बाजूला आपण दाखवलेले आहे. Okay, this is the second possible stereoisomer. Now let us see third one. Okay, this is the third one. यामध्ये आपण काय दाखवलेले आहे, फर्स्ट OH ऑन द राइट हँड साइड अँड सेकंड OH ऑन द लेफ्ट हँड साइड. ओके, अँड दिस इज द थर्ड स्टेरिओआयसोमर. नाउ अगेन नेक्स्ट वन. हियर दिस इज द एक्झॅक्टली वाइस वर्सा. फर्स्ट OH ऑन द लेफ्ट हँड साइड अँड सेकंड OH ऑन द राइट हँड साइड. ओके, दिस इज द स्टेरिओआयसोमर नंबर 4. अँड thus for 2,3-dihydroxybutanoic acid we have shown 4 possible stereoisomers. These are the 4 possible stereoisomer, and here we have shown the different arrangement of atoms or group around the chiral carbon. We have shown different arrangement of atoms or group around the chiral center. Okay, now let us see some relation. Actually, all the 4 compound, all the 4 stereoisomer, they having chiral center. They having chiral center, and they do not having any element of symmetry. Suppose this is the plane passing through molecule. This is the plane passing through molecule. Is it divide that plane into 2 equal part? ते त्या moleculeला equal part मध्ये divide करतं का? नाही. Because एका बाजूला आहे COOH, दुसऱ्या बाजूला आहे CS3. Means there is a no plane of symmetry. There is a no plane of symmetry. Similarly, we do not having alternating axis of symmetry. There is no center of symmetry. Thus, all the 4 stereoisomer, they contain a chiral carbon, and also there is a no any element of symmetry. Hence, all the 4 stereoisomer are optically active. माझं पहिलं स्टेटमेंट लक्षात ठेवा. All the 4 stereoisomer, they having chiral center. There is a no any element of symmetry. Hence, they are optically active. They show optical activity. Okay. Now let us see relation between first and second. पहिल्या 2 मध्ये आपण रिलेशन बघूया. सपोज दिस इज द मिरर बिटवीन दॅट 2. दोन्हीच्या मध्ये मिरर आहे असं आपण कन्सिडर करूया. नाउ माय फर्स्ट क्वेश्चन, आर दे मिरर इमेजेस ऑफ इच अदर? येस, दॅट 2 फर्स्ट अँड सेकंड, दे आर मिरर इमेजेस ऑफ इच अदर. ते एकमेकाच्या आरशामधील प्रतिमा आहेत. तुमच्या लक्षात येतंय का आरशामधील प्रतिमा म्हणजे कसं? तुम्ही तुमच्या चेहऱ्याच्या समोर, तुमच्या फेस समोर मिरर पकडला, धरला, तर तुमच्या चेहऱ्याचा जो बाजू समोरची आहे ती बाजू आरशामध्ये समोर दिसते. म्हणजे तुमचं नाक एकदम समोर असेल, आरशामध्ये नाक समोर दिसेल. कान पाठीमागे आहेत, पाठीमागे दिसतील. डोळे वरच्या बाजूला आहेत, वर दिसेल. या पद्धतीनं. हिअर ऑल्सो सपोज दिस इज द मिरर. मग इथं OH समोर आहे, या इथं OH समोर आहे, आरशामध्ये पण समोर दिसेल. बरोबर, हा OH पण समोर आहे, इथेही समोर दिसेल. Means that first and second, that 2 are mirror images of each other. आता आपण काय बघूया. सपोज यामधली एक इमेज आपण उचलली आणि दुसऱ्यावरती मॅच करायला गेलो. आर दे मॅच विथ इच अदर? ते मॅच होतील का? एक इमेज उचलायची आणि याच्यावरती ठेवण्याचा प्रयत्न करायचा. इमॅजिन करा म्हणजे इथं H आहे त्यावरती OH येईल. मीन्स दॅट टू इमेजेस डू नॉट मॅच विथ इच अदर. This indicates that first and second, they are optical isomers. They are optically active. Why they are optically active? I have already explained that. Because that first and second, they contain a chiral carbon. They do not having any element of symmetry. Hence, they are optically active. Okay. First and second, they are optical isomer. And also, they are non-superimposable mirror images of each other. Non-superimposable mirror images of each other. Hence, first and second are enantiomers. They are called enantiomers. Magashi आपण पाहिलं होतं what is meant by enantiomers. Okay, they are optically active and they are non-superimposable mirror images of each other. Hence, they are enantiomers. Okay, now let us see relation between third and fourth. Third आणि fourth मधलं relation आपण बघूया. Suppose this is the mirror between that two. Now, what's about third and fourth? Are they mirror images of each other? Are they mirror images of each other? Here also they are mirror images. कारण वरच्या बाजूचा OH समोर आहे, अर्शामध्ये समोर दिसतोय. त्यानंतर नेक्स्ट पुढचा OH पाठीमाग आहे, अर्शामध्ये पाठीमाग आपल्याला दिसतोय. Means that two are mirror images of each other. Okay. Now what's about? Suppose यामधली एक इमेज आपण उचललं आणि दुसऱ्यावरती मॅच करायचा प्रयत्न केला. They do not match with each other. Means that two are non-superimposable mirror images of each other. Third and fourth, they are also non-superimposable mirror images of each other. Okay, and thus here also third and fourth, they are optical isomers. They are optically active and they are non-superimposable mirror images of each other. Hence, they are called enantiomers. Okay, and thus here there are two pairs of enantiomers. First and second, and third and fourth. These are the pairs of enantiomer. यामध्ये कुठल्या दोन पेअर आहेत? पहिली आणि दुसरं आणि third and fourth. These are called enantiomers. Here first and second and third and fourth, they are enantiomers. Okay. Now let us see again relation between first and third. आता मी तुमच्यासाठी क्वेश्चन विचारतो. What's about the first and third? पहिला आणि तिसरा. First and third. What is the relation between first and third? Are they mirror images of each other? No, they are not mirror images of each other. पहिला आणि तिसरा mirror images नाही. बरोबर? And thus stereoisomer first and third are not mirror images of each other, and such stereoisomers are called diasteromers. त्यांना आपण म्हणतो diasteromers. The stereoisomers which are not mirror images of each other. Very simple concept. The stereoisomers which are not mirror images of each other are called diastereomers. Here first and third. What's about the first and last, first and fourth? They are also not mirror images of each other. Hence they are also called diastereomers. Similarly, let us see relation between second and third. Second आणि third या दोन्हीमध्ये काय रिलेशन आहे? Here also in second and third, they are not mirror images of each other. Similarly, second and fourth, दूसरा आणि चौथा, they are also not mirror images of each other. Hence they are called diastereomers. First and third, first and fourth, second and third, and second and fourth, these are the pairs of diastereomers. यांना आपण diastereomersच्या pairs असं म्हणतो. Means those stereoisomers which are not mirror images of each other are called diastereomers. Okay, मग आपण मगाशी पाहिलं होतं enantiomers. पुन्हा आता एक्झाम्पल आपण पाहिलं 2,3-dihydroxybutanoic acid and how that 2,3-dihydroxybutanoic acid having 4 possible stereoisomer and relation between them हे आपण बघितलं. आणि यामध्ये आपण पाहिलं actually what is the enantiomers and how there is a diastereomerism ते सुद्धा आपण त्यामध्ये पाहिलं. Let us see some properties of diastereomers. Okay, suppose these are the 4 possible stereoisomers for 2,3-dihydroxybutanoic acid. Now let us see properties. यामध्ये पहिला पॉइंट एक लक्षात घ्या. Generally, diastereomers are observed in compound which having more than one chiral carbon. Those which having more than one chiral carbon. त्यामध्ये आपल्याला means diastereomers must have more than one chiral carbon. Lactic acid do not having diastereomer कारण त्यामध्ये एकच कार्बन होता. but 2,3-dihydroxybutanoic acid having 2 chiral carbon, and therefore they having diastereomers. Okay, this is the first property. They must have more than 1 chiral carbon. Second, they are not mirror images of each other. Okay, आपण डेफिनेशन मध्ये सांगितलेलंच आहे. They are not mirror images of each other. Okay, they have different physical properties like melting point, boiling point and density. हा मात्र महत्वाचा पॉइंट आहे. Means there is a slight difference in the MP, melting point, boiling point or density of that diastereomer. म्हणजे इथं पहिला आणि तिसरा हे डायस्टेरियोमर्स आहेत, तर त्यांच्या एमपी मध्ये किंवा त्यांच्या फिजिकल प्रॉपर्टी मध्ये देयर मे बी सम स्लाइट डिफरन्स, and therefore this is the third point. They are having different physical properties like MP, BP and density. Okay, then last, they have similar chemical properties, but their chemical properties are not different, they are similar. Okay, this is just about the diastereomers. आज आपण दोन टर्म्स पाहिल्या. फर्स्ट वन इज द इनॅन्शिओमर अँड सेकंड वन इज द डायस्टेरिओमर. हे दोन्ही टर्म्स खूप इम्पॉर्टंट टर्म्स आहेत. ठीक आहे, यामध्ये इनॅन्शिओमर्स म्हणजे काय, तर ऑप्टिकल आयसोमर्स विच आर नॉन सुपर इम्पोजेबल मिरर इमेजेस ऑफ इच अदर. यामध्ये सिंपल एक्झाम्पल पाहिलं आपण लॅक्टिक ऍसिडचं. आणि सेकंड टर्म बघितलं डायस्टेरिओमर्स, द स्टेरिओआयसोमर्स विच आर नॉट मिरर इमेजेस ऑफ इच अदर. व्हेरी सिंपल टर्म ऍक्च्युअली आर कॉल्ड डायस्टेरिओमर्स. यामध्ये एक्झाम्पल पाहिलं आपण 2,3-dihydroxybutanoic ऍसिड. आणि मग त्यामध्ये डायस्टेरिओमर्स कसे ऑब्झर्व होतात तेही आपण बघितलेलं आहे. यामध्ये आणखीन एक टर्म मी फक्त रिवाइज करणार आहे, ऑलरेडी आपण बघितलेलं आहे, फक्त पुन्हा एकदा रिवाइज करूया. व्हॉट इज रेसिमिक मॉडिफिकेशन? रेसिमिक मिक्सचर इज ऑल्सो नोन ॲज रेसिमिक मॉडिफिकेशन. रेसिमिक मिक्सचरलाच रेसिमिक मॉडिफिकेशन असं म्हटलं जातं. नाउ व्हॉट इज द डेफिनेशन ऑफ रेसिमिक मॉडिफिकेशन? द इक्विमोलार मिक्सचर ऑफ dextroanilioisomer of an optically active compound is called racemic mixture. म्हणजे डेक्स्ट्रोअनिलिओआयसोमरचं इक्वल प्रपोर्शन मध्ये मिक्सचर असेल, दॅट मिक्सचर इज कॉल्ड रेसिमिक मिक्सचर और रेसिमिक मॉडिफिकेशन. द इक्विमोलार मिक्सचर ऑफ डेक्स्ट्रोअनिलिओआयसोमर ऑफ एन ऑप्टिकली एक्टिव कंपाउंड इज कॉल्ड रेसिमिक मॉडिफिकेशन. इट इज डिनोटेड बाय DL or plus minus sign, and keep in mind it is optically inactive due to external compensation. ते ऑप्टिकली इनएक्टिव्ह आहे ड्यू टू एक्सटर्नल कॉम्पेन्सेशन. मी तुम्हाला दाखवलं होतं, पुन्हा एकदा सांगतो. सपोज दिस इज द PPL, प्लेन पोलर लाईट, अँड ओके दिस इज द ट्यूब हॅव्हिंग रेसिमिक मिक्सचर. यामध्ये रेसिमिक मिक्सचर आहे, म्हणजे डेक्स्ट्रो आयसोमर आणि लिओ आयसोमर याचं इक्विमोलार प्रपोर्शन त्यामध्ये आहे. ओके, सपोज दॅट PPL इज पास्ड. यामधून आपण PPL पास करूया. PPL यामधून पास होताना काय होतं? Dextroisomer rotate the plane of PPL in clockwise direction. Dextroisomer rotate the plane of PPL in clockwise direction, means towards right side. While Leo-isomer, त्यामध्ये Leo-isomer सुद्धा आहे in the same amount. That Leo-isomer rotate the plane of PPL towards anti-clockwise direction. म्हणजे तो anti-clockwise direction मध्ये फिरवतो तेवढ्याच अँगल मधून. Means resultant effect is no rotation. मग त्या ठिकाणी त्यानं जेवढ्या अँगल मधून फिरवलं राईट साईडला, तेवढ्याच अँगल मधून उलट बाजूला तो फिरवतो राईट लेफ्ट साईडला, अँड देअरफॉर रिझल्टंट इफेक्ट इज नो रोटेशन. म्हणजे याला आपण काय म्हणू शकतो? द रोटेशन कॉज्ड बाय डेक्स्ट्रोआयसोमर इज नलिफाईड बाय लिओआयसोमर, अँड दिस इज कॉल्ड एक्सटर्नल कॉम्पेन्सेशन, अँड देअरफॉर इट इज ऑप्टिकली इनएक्टिव्ह. म्हणून रेसिमिक मिक्सचर हे ऑप्टिकली इनएक्टिव्ह आहे. ओके, देन देर इज वन मोर टर्म रिगार्डिंग दॅट, रिझॉल्युशन. रिझॉल्युशन आपण कोणाला म्हणतोय? The separation of dextroanilioisomer from its racemic mixture. The separation of racemic mixture into dextroanilioisomer, it is called as the resolution. The separation of dextroanilioisomer from its mixture is called as the resolution. Okay, and here suppose that racemic mixture is separated into dextro as well as leo-isomer, then it is that process is called resolution. It can be carried out by different method. वेगवेगळ्या मेथड आपण ते करू शकतो. फॉर एक्झाम्पल मेकॅनिकल, biochemical or chromatographic method. That separation can be carried out by using that different method. Okay, this is just about the racemic modification, racemic mixture. The equimolar mixture of dextro and leo-isomer is called racemic mixture. It is denoted by DL. It is optically inactive. and separation of dextro and leo isomer from its mixture is called resolution, and we can carry out by chromatographic technique, some biochemical method, and also by mechanical method. Okay, this is just about the racemic modification.